Hello everyone, welcome back. This is Ahmed for Avionics and we are in Mastering Docker course. In this section we are going to study how to use Docker containers, which is an integral part of any Docker installation and usage. Now, before we get started with Docker containers, let's have a look at a very important aspect in Docker, which is how to get help during your work. In the previous section we have seen how you can write different Docker commands on the command line. And Docker is a command line tool. Actually, it does not have a GUI interface, so you're going to use the command line in order to interact with Docker. Some people might find this a little intimidating because of the large number of commands, different commands and flags and options that can be used. And for this, Docker provides you with a special assistance system which can be accessed using --help, either following the Docker command itself or following any of the subcommands that you can use with Docker. So let's see an example. This is our example system here. We're using Ubuntu 16.04 and this is an SSH connection to the virtual machine. And here I can use Docker --help. Also notice here that I'm using root as the user to be working with Docker. That is instead of having to write each time sudo before using Docker. For saving time and keystrokes, I have logged in as root. So back to our topic. If I type Docker --help and press enter, I will be presented with all the subcommands that can be used with Docker with a brief description to each command of them, as you can see here. And you can also, let's clear the screen, use Docker help to find help about any subcommand. So for example, let's say Docker pull. If I need to know what Docker pull does or what are the available options that can be used with Docker pull, I can write Docker pull --help and press enter, and this will give me another brief description of the subcommand, pull an image or a repository from a registry. These are the available options or flags that can be used with Docker pull. Now in the following lab we are going to create a container, or two containers actually, and in this lab we want to demonstrate a very important cornerstone of Docker, which is how you can link two containers together. Linking will be covered in detail later in this course, but in this lab I just want you to understand that we can have two containers and those two containers can interact with each other. So our target here is to create or to launch a container, just a server, and we're going to use BusyBox for this. And BusyBox, if you don't know it, is a tiny Linux kernel with the most basic Linux functionality, and it is used to create test environments, and it can also be used for some advanced use cases. So in this lab we are going to use the BusyBox image to create a very basic container. This container will just run a simple script that launches an infinite loop, just a loop that is going to be running in the background, and it does nothing, just to ensure that the server will keep on running. And that is because a container will only run as long as the command that it runs is working or is running. The moment the command exits, the moment the script that this container runs exits or fails or stops for any reason, the container just exits and it's no longer running. So for that I have created this image. It is called afakharani/server, and now I'm going to pull and run this container on my machine. So it's docker run. Let's use the --name flag to give this container a name. Let's name it server to be somewhat descriptive, and let's use -d or --detach, which is the longer version of the flag. And this is just used to make sure that this container runs in the background, because by default the container will run in the foreground. So let's use -d or --detach, and then let's pull the image from the Docker registry. Okay, it's called afakharani-server. And before doing this lab I have already downloaded the image from the Docker Hub just to save time. So here I have my container. I can use Docker ps in order to display the available containers, all the running containers, and yes, I can see here that I have a container running with an image afakharani/server, and the command that it's running, as you can see here in the output, is /runner/runner.sh, which is, as I have just mentioned, a script that will just create and launch an infinite loop in the background just to keep this container running in the background. Now the second container that I want to pull and use is called checker. And the checker container is also using the BusyBox image, but this time it is using a script that is used to send ping requests to the container. It is used to send ping requests to server container, and it waits for just the first ping request to return. If it returns successfully, If there is a response from the server, this means that the server is up, so it's going to write server is up, okay? However, if this command fails, if the ping request fails for any reason, it will just print server is down, and it's going to exit. So think of it just like a very, very basic monitor for a container. Of course, this by any means cannot be used to monitor a real container, but we are using it here just for demonstration purposes and to show you how we can link two containers together. Now let's pull and run the image, and let's first run it in the interactive mode. So we're going to use -t or -- interactive, and this will ensure that the container will run in interactive mode, which means that it's going to be interactive in the command line, just like any process or any command that you run in your shell. And -t, which is short for -tty, this means that this container will accept and respond to normal signals passed in by the shell. Like for example, when you're running a command in Linux and you want to exit this command, you just press Ctrl+C to exit this command. Using -t or -tty will ensure that the container will behave as if it was any Linux process. It will accept the signals that you send to it using the command line or using the shell. And I can combine both of them like this to be docker run -it, and then let's give it a name, call it checker, and I'm gonna pull and run this image or this container from the Docker Hub. So it's a fakharani/checker. Let's run it. Okay, and as you can see here, it gave me bad address, server is down. This means that it couldn't find a container with the name server, and that is because we did not link it to the server. It does not know of any container that is called server, and to do that you will have to use --link, and as I mentioned, linking will be covered in detail later in this course. Just add here the container name, which is server, and the name that will be used inside the container itself. Let it be just server again, and let's run it again. Okay, and because we have used checker before as name, we cannot reuse this name again, so we will have to remove this name using docker rm. Let's use -f to force the container to be deleted. So let's remove checker. Okay, and now let's run it again with the linking enabled. And as you can see here, it is typing server is up. It's going to type this message every 5 seconds. The script is configured to run every 5 seconds, send a ping request to a container or a machine that is called server, and print out the result of this command. If it's successful, server is up. If it is not, then server is down. Now if you press Ctrl+C like this, as you can see, the container has exited. If you have docker ps, you will see that we will have only one container running. Now let's try and run this container in the background instead of -it. Let's run it with the -d flag like this. Okay, and again we'll have to remove checker because it exited and it was using this name. I have to delete it and then run the command again. Okay, now if I run docker ps, I will see that I have two containers running in the background. The first one is the server, which is the loop that is running in the background, and the second one is checker, which is the ping requests that are sent to the server. Now let's try and stop the server using docker stop. Docker stop will just stop the container. So I'm gonna stop server. It's gonna take just a few seconds to respond. Okay, now it has stopped. If you have a look at ps, I will see that I no longer have any containers. Why? Because the checker command, as we have mentioned, sends ping requests to the server, and this is the only command that is running in the container. If this command fails, because of course it's gonna send the ping request to a server or to a machine that is no longer running, so the command will fail and the whole container will just exit. So now I have no containers running in the background. But notice here that since I'm running this checker in the background, I can no longer see what's happening behind the scenes. I can no longer see the messages that it is printing to my standard output because I'm running it in the background. In the next lecture, we are going to see a way to have a look at what this container is printing to the screen to see what exactly is happening. So see you next.